So we're going to start with the basics, which is basically Lee-Shatler principle that you've got reversible reactions. What's a dynamic equilibrium by definition? That it's when a rate of forward reaction.
Haven't we already done this topic?
Okay, it's written. I mean KP, right?
Oh no,
You haven't
I
done
don't think we done
you
this.
haven't done weak
Yeah.
acids, or I mean you haven't done this. What you have, I mean, you've done, I think, procedurally acid-based, I mean, just the acid-based concept, right? You know about that. You know about where was KP? This one, right? Okay, that's, I mean, this one is showing that it's in A levels. I mean, it's the same as KC. You did KC and we did do KP.
Yeah.
So we'll just quickly like go through this, TK, because the Equilibria concept
Okay.
is, so we'll just quickly revise this. Because the whole acid base and all that stuff, that's also related to this.
Okay.
So now dynamic equilibria is what, when the rate of forward reaction. What does it do? It equals the rate of backward reaction, right? As I said, since you've already done this part, we can jump to past paper questions related to this. Okay, we can start off with KC questions. Starting with the first one, can you tell me what the expression for KC in this case is?
Is it C?
It's
No, sorry. D.
T gets D. Then this one, I'll do one for you. You had to figure out the value of. So you had to figure out the value of KC in this case, right? So you got this reaction. How did you do this question? There were two types of questions. One was that you would just make a table, a rough table. Now you've got 2HI. You've got your initial moles. So there's 2 moles of hydrogen, and there's 3 moles of iodine. And initially there is no HI, right? So there's 0 moles of HI. And then he says that at equilibrium, there are 2.4 moles of iodine present, right? You started off with 3 moles, and at equilibrium, you're left with 2.4 moles. So that means how many moles got used up? That means 0.6 moles reacted, right? Is that clear? And
Yep, it's clear.
as Hopper said, it's 1:1, so that means 0.6 of H2 would also react, right? And together on the other side, they're going to produce 1.2 HI getting produced. It's 1:1:2, right? So your moles at equilibrium would be, this would be 1.4 moles, and this would be 1.2 moles, right? TK, is this clear?
Yep.
So those are your moles, and since those since those are your moles, now what you're going to do is you're just going to write Kc. Now in Kc you use concentration. The container has a volume of 1 dm cube, so that means the concentration is going to be exactly the same. So it's just going to be Kc would be 1.2 squared. Up here it's going to be bottom pick 1.4 times 2.4, right? Is this clear?
Yep. The answer is C.
Okay, so in this case, it's C. Um, Try doing this one then. Tell me what the answer is. It's kind of the same question.
Is the answer C?
Okay, for this one, it's C. It says, what's the value for Kc for reaction number 2?
Is it B?
No, it's not B. Okay, you figure this out or not?
Is it A?
ठीक है, it's going to be A. ठीक है, both of them, they're the same reaction except that they're the other way around. So I mean, the product is the reactant over here. The reactant over here is the product over here. ठीक है, so it's upside down. ठीक है. Plus, the coefficient is, I mean, it's going to get underrooted because everything has been halved. ठीक है. अच्छा, फिर what's the unit for Kc over here?
Is it B?
अच्छा, इसका हाँ भी है. अच्छा, then what's the answer to this one?
I'm not really sure how to do this question.
Okay, for this one, it's going to be trial and error. Okay, so let's say we pick D. So क्या होगा? It's going to be 2p and q plus 2r, right? So your initial moles are that you got 2 moles of p, right? And there is no q and there's no r. And at equilibrium, there's x moles of r, right? So that means at equilibrium, you got x moles of r. So if you've got x moles of r, so that means x moles got produced because you had 0 initially, right? Ye clear?
Why is there a 2 in front of the R?
Yeah, I just took equation number D.
Oh, okay.
Okay. So x moles
Yeah.
got produced. So how many moles of Q would be produced? If x of R are produced, so how many moles of Q would be produced?
X over 2.
Okay, so that's going to be x over 2. Produced, and I think minus x x reacted, right? So what are your final moles for P and Q? That's for this it's going to be 2 minus x, and for this it's going to be x over 2, right? So these are your total moles at equilibrium. And if you add them up, it's going to be what? It's going to be 2 plus x over 2. Okay, is this clear? So the total number of moles present is 2 plus x over 2. So that is true for D. Is this clear?
Yep.
Just similarly, then you have the reverse as well, which is that Kc would be given, and you have to find the original moles. Do you know how to do this?
Do you just substitute it into the equation and then just rearrange it to find it?
Okay, so your initial moles were that you had 1 mole of this and 1 mole of this, right? And there's 0 moles of this and 0 moles of water, right? तो इसके बाद क्या करोगे? You have to find the equilibrium moles.
So is the 1 mole not the equilibrium moles?
Nee, that's
Is that the original?
that's the initial moles.
Okay.
So what are the equilibrium moles? So you're gonna assume that you don't know how many of them reacted, right? So you're gonna assume that x moles got reacted. So if x moles got reacted, you're left with how much? That's 1 minus x. X moles of this would have reacted as well. So that's 1 minus x. And on the other side, everything is 1:1. So x moles got produced, x moles got produced. So your equilibrium moles will be 1 minus x, 1 minus x, x, and x. Is that clear?
Yep.
To find the value of x now.
But if you add that up, you get 2.
Nee,
Or
you're
do you
not,
have to equate?
nee, you're not going to add them up. What is the Kc expression? That's going to be x squared over 1 minus x squared, right? Your Kc value is 4, so you're going to find they've given you the value of Kc, right?
I got 2/3.
ठीक है, so it's 2/3. X is 2/3. ठीक है, that's fine. Um, इसका बता दो, what's the Kc expression in this case?
Is it D?
ठीक है, this one, हाँ ठीक है, D है. अच्छा, so this is 2/3 again. 1 second. Just go find the equilibrium moles for this question. Kc is given. The initial moles are given. This, and this. They're all given.
I don't understand how you're supposed to find the final moles.
So again, you don't know how many moles reacted, right? So let's say
So
X.
do you just put X in? Okay.
So it's all 1:1. So it's X reacted. On the other side, X got produced. Are you done with this?
Not yet. I got two answers. 5.7 or 0.25.
So which one is the correct one? Because your moles, I mean, if you look at your moles cannot be negative. So which one? Because it's a quadratic equation, okay? So you're gonna get both plus and minus values. So which X value would give you negative moles?
5.7.
ठीक है, so you're not going to use 5.7, ठीक है? You clear?
Yeah.
So let's try and do so this is KC, right? So let's try and do KP questions. There's one additional thing in KP, and that's that you have to find partial pressure before you calculate KP. So KP is so in KP you use partial pressures, and you can even do this with percentage. So if
Mm.
he's saying that 50% is getting dissociated, right? N2O4, dinitrogen tetroxide. So you don't even need moles in this because you just need percentage of what quantity is present. So if we start off with, let's say, 10 moles, so यहाँ पे ना N2O4, that's 10 moles, right? 50% get dissociated. So you're left with 5. 5 goes to the other side, so that means on the other side you're going to have 10 moles. Is that clear?
Yeah, that's clear.
So KP is the same, product over reactant, but before that you have to calculate the partial pressure. So 5 out of 15, that's the mole fraction multiplied by the total pressure, which is 1 atmosphere. So 1 atmosphere pressure is the pressure that's exerted by the entire container. So the pressure that's exerted by N2O4 only, that's 1/3, okay? Is that clear?
Yep, it's clear.
And the other side, that's going to be 10/15 into 1 atmosphere. So it's basically 1/3 and 2/3. And Kp would be product squared, so it's 2/3 squared divided by 1/3. So you're going to get 4/3. TK, is this clear?
Yep, it's clear.
So let's come to the next one. What's the expression for 20% of steam is getting dissociated? So you can just think of this as starting with 10 molecules, 20% getting dissociated.
So is it 2 out of 10?
Get that 2 out of?
Is it?
No, let's say you start off with 10, right? As so let's say you start off with 10. तो अब पीछे कितने रह गए? How much is left?
8.
So you guess you're left with 8, right? What do you get on the other side?
Um, do you mean in the denominator?
Yeah, how much H2 and O2 is going to get produced?
Is it the same for H2
It's going to
and
be
then O2?
it's going to be 2 and 1 because 2 reacted, right? Is this clear?
No, I don't really understand.
Yeah, out of 10, 20% got dissociated. So that means 8 is left, right?
Yep.
So how much reacted, right? Two of them reacted, right? 2 got dissociated.
Okay, that makes sense.
You can now find the partial pressures. So it's going to be 8/11, right? Mole fraction multiplied by the total pressure, which is 1 atmosphere. This will be 2/11 times 1, 1/11 times 1. ठीक है? तो कौन सा which answer is correct?
Is it D?
ठीक है, so it's going to be D. This ये तो आसान है, this one. So this one, find the value of Kp for this. I mean, all the information is given over here. Basically, just find the value of
Okay.
Kp. हो गया, done with this.
Is it 3.24 times by 10 to the power minus 7?
How many moles did you get for you started off with 2, right?
Yeah.
2 of this, right? And then you had 1.84 moles, so that means that's at equilibrium 1.84. So that means 0.16 went to the other side, so that you got 0.32 on the other side, right? यही था.
I think I did it the other way by mistake. So I think I started with 2 moles of 2 and
So
O2.
so basically, I think you just invert your answer basically. No,
Yeah,
you would get the numbers wrong as well because you said that this was 2 moles,
there
right?
would be a different amount of moles, yeah.
ठीक है. So ठीक है, then obviously your answer is wrong because हाँ ठीक, your answer would be wrong in that case. You can't really change that.
So,
You would have to
so
be,
what's the answer?
then it's going to be 0.32 divided by what, I think 2.16, and this would be 1.84 divided by 2.16 times what's the pressure? That's 140. And then this is the numerator, this is the denominator, so square that. So this divided by this.
Do you have to do 140,000 or just keep it as 140?
Keep it as one, then your unit would be kPa then.
Okay.
Then it will be kPa minus 1 basically. It's going to be pressure of N2O4 divided by pressure of NO2, and that's going to be squared. So it's going to be kPa minus 1. ठीक है, is this clear?
Yeah, that's clear.
So give me the kP value for this one, just the last one. This is, I think, what's the equation? We don't have an equation. It's I guess it's SO2, 2SO2 plus O2 and 2SO3. Find the value of kP for this.